That's not good. Alright guys, so we're live right now. Oh, sorry. Look at this worksheet right now. So sorry about that. Okay. This relies on a unit circle. I was just trying to be able to fit both of these. I don't know if it does that, but okay. Give me 1 second, guys. I just want to make sure we're all good here. Hold on a second. Okay. All right, so we're going to be looking at this right here. All right. So I wanted to be able to put the circle, the unit circle, so we can actually look at it better. But let's try to answer your questions as is. If not, I'll have to put up the unit circle for you so you guys can take a look at it. Unit circle with the trig ratios on it. In any regards, let's see. So he wants to determine the exact value of t. Point M is located in the second quadrant on the unit circle. So, and the value for y is 4/7. Determine the exact value for t. Let's see something. Trying to figure out a good way to show you guys this. So it's in the second quadrant, which is this quadrant right here. We're really dealing with a positive sign, and we're dealing with the positive cosecant. Remember the identities I showed you guys before? So let's look at sorry about that. So let's look at this right here. So we're over here dealing with second quadrant, right? So keep in mind that what the slope is essentially rise over run. So the rise value right here is going to be the y value. The y value is going to be 4, right? And we're run over 7. So keep in mind this is the first quadrant, second quadrant, third quadrant, fourth quadrant. He's telling me that the point M is 4/7. The point for y is 4/7, right? They want to be able to find what t is, which essentially would be the x value right here. So it's 4/7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 7. Okay, and 4. 1, 2, 3, 4. adjust that a little bit here. Oh, come on, get lost. Yeah. Ah, come on. Make it clearer for you guys. So we're dealing with opposite sign, right? It's opposite over hypotenuse. There's no hypotenuse here. There's no value right here, right? So we're going to be dealing with tangent. Opposite 4/7. Now they want to be able to know from this angle. One second, guys. Give me 1 second, guys, right? Sorry about that, guys. All right. Yeah, okay. So just keep in mind with this right here. Let me do this a better way for you guys. Keep in mind right here. Again, this is a unit circle, right? So that means when we go fully 360, all the radiuses are one unit, right? Keeping in mind that if we're looking at this right here, they tell me that point M, right? Point M is somewhere, we don't know where the x coordinate for point M is, but we do know essentially where the y coordinate is. The y coordinate is essentially 4/7. All right, let's do it that way. It's a little bit better. So in essence, we need to be able to find this, call it X and call it B, right? Let's call it B, right? This is A, this is B, and then we have 1. So we're going to be using SOHCAHTOA. SOHCAHTOA says A squared plus B squared equals C squared, right? Again, we have a right triangle right here. So our A squared is going to be 4/7 squared. Our B squared, we don't know what that's going to be. And our C squared is going to be 1 squared. So we want to be able to find what B squared is, which essentially will give us the X value. I don't know if you see that. You understand that? Or a T value. Let me call this T. Sorry, let me call it T. Make your life a little easier. I call it T squared. T squared, right? Let me call it T. T. Okay. So now we have 4/7. We're going to square that, right? Plus T squared is going to be equal to C squared, right? C squared in this case is going to be 1. Let's square out our A squared first and get a common denominator. So when we square our A squared, we're going to be left with 16/49. And we're going to understand how I got that. Space is small. Okay. 16/49. Plus T squared equaling, To make my life easier, I'm going to use 49 over 49, which is equivalent to 1, which is what 1 squared equals, right? So I'll say 49 over 49, right? And then use the space right here. Sorry guys, I'm gonna erase that part. So it's gonna be 49 over 49 minus 16 over 49 equals t squared. So 49 minus 16 is going to be equal to what? 33. So I have 33 over 49 equals t squared. And t is going to be equal to square root of 33 over 49. Which essentially is just going to be I'm putting different colors so you guys don't get confused. Essentially going to be, let's erase that part. Everyone saw what I did over there. Oh, come on. Essentially it's going to be square root 33 over square root 49, which equals to square root 33 over 7. That equals t. Everyone understand that? I'm gonna put a sheet next for you guys to look at. 2 says, in the accompanying diagram of a unit circle, the ordered pair. Everyone clear on that, right? Sorry about that, guys. Make sure you guys are also submitting your work if you can to Google Classroom too. I've been grading that. All right. Some people have been able to scan it, print to scan it. You know. Yeah. Sorry, I was just looking at that. Okay. So right here. So it says in the accompanying diagram. In the accompanying diagram of a unit circle, the ordered pair x and y represents the locus of points forming the circle. Yeah, I haven't gone over this. I'm not sure if you guys went over this when you guys took geometry or maybe in algebra. But the locus of points is just a given set of points that follow an instruction. Like the locus of points, an equidistance from a single point would be what's equivalent to a circle, right? So that's what the locus of points is. It says which ordered pair. Okay, so it says which ordered pair is equivalent to x, y. So we want to know what's going to be equivalent to x, y. How can we find what the x, y is equal to? Remember, this is a unit circle, right? So x, y has coordinates, which would be what? Keep in mind what represents y, what represents x in the ordered pair. Essentially, y is represented by sine, and x is represented by cosine. So cosine, sine. I think I had mentioned this in class before. The outbreak. Question 3. Yeah, let's try question 3, and then I'll assign this sheet to you guys to look at. Probably 1 through 5. Maybe more. I'm not sure. But then we can look at it again tomorrow. So it says point A is 1/2 at radical 3 over 2 is on point A, 1/2 radical 3 over 2 is on a unit circle whose center is at the origin, is the origin. If theta is an angle in standard position whose terminal ray passes through point A, what is the value of sine theta? Right, so I want to draw up that unit circle. Oh man, I wish there was a way I could. It's a unit circle image. Let's go back to this real fast. There we go, unit circle, all right? And the axis in this question, let me see. What are the axis in this question? They're asking us in the accompanying diagram. No, axis is that. Let me see. Point A is 1/2 and radical 3 over 2. So 1/2 radical 3 over 2. Okay, so there we are, 1/2 radical 3 over 2. Right? If theta is the standard position, if theta is an angle in standard position whose terminal ray passes through point A, all right, then they want to know what is the value of sine theta. So sine of theta, they want to know what's the value of sine of theta. Sine of theta is going to be your positive sine theta is going to be the sine of 60 degrees. The sine of 60 degrees is going to be, let me see, I'm using my calculator here. I think it's 1/2, let's see. Clear. Sine 60 degrees. It's radical 3 over 2. So actually, it makes sense. It's radical 3 over 2. Let me see. What are you asking? What is the value of the sine of theta? What is the value of the sine of theta? Right. So it's radical 3 over 2. Keep in mind that that pretty much answered what we had above. Remember, the y value always represented sine. All right. All right, guys. If you have any more questions, if you don't have any more questions, does anybody have any questions? Please let me know right now. If not, then I'm going to end this session and I'll post this. All right, guys. Let me know. All right, guys. So I'm going to end the session. Have any more questions? Question me through Google Classroom, or also question me through the comment section. All right. We'll go over this sheet again tomorrow. I'll post it today.